For thousands of years, the absolute speed limit of human progress was set by biology. If you needed to move heavy materials or travel long distances, you relied on the raw muscle of humans or animals. When James Watt refined the early steam engine in the late 1700s, he needed a way to explain this new mechanical energy to mill owners. He calculated the exact amount of work a single draft horse could do in a specific time frame, coined the term horsepower, and used it as his core marketing pitch. The transition from muscle to machine took time. In 1830, an American engineer named Peter Cooper pitted his early steam locomotive, the Tom Thumb, in a literal race against a horse. The engine pulled ahead at first, but a crucial leather belt slipped off the blower. By the time Cooper fixed the blistering hot engine, the horse had won. Despite the rapid innovations of the Industrial Revolution, economic growth remained physically bottlenecked. Canals and dirt roads simply could not handle the sheer volume of raw materials that factories were starting to demand. The solution began in the coal mines, where massive, stationary steam pumps cleared out water. Engineers realized that by shrinking these designs into high-pressure systems, they could create self-moving vehicles. By 1803, British inventor Richard Trevithick successfully placed one of these engines on a set of iron tracks. The definitive test for this new technology came at the 1829 Rainhill trials in England. Railway directors set up a strict competition to find the most efficient and reliable locomotive design, capable of hauling heavy loads over distance. George Stephenson's entry, the Rocket, decimated the competition. Hitting speeds of 36 miles per hour, its design, featuring a multi-tubular boiler and external cylinders, set the mechanical standard for all future engines. The Rainhill trials provided the definitive engineering template for the locomotive.
With the Rocket's success, the debate over the future of transit ended, providing the mechanical blueprint required to begin the rapid expansion of rail networks across the globe. In the United States, the completion of the Transcontinental Railroad rapidly accelerated national expansion. By replacing month-long, dangerous overland wagon journeys with a unified rail network, the cost of a coast-to-coast trip plummeted by 85%, immediately opening Western markets to Eastern manufacturing. To the north, the Canadian Pacific Railway achieved a similar feat in 1885. It linked the fertile prairies of the West to the ports of the East, allowing thousands of new immigrants to settle the interior and transforming isolated grasslands into a primary source of exported wheat. But this massive infrastructural triumph carried severe social costs. The intense demand for cheap labor brought thousands of migrant workers, particularly from China, into newly forming Western towns, sparking violent racial tensions from local populations. This anti-migrant backlash reached the highest levels of government with the passing of the Chinese Exclusion Act of 1882, legally banning Chinese laborers from entering the United States for decades. The iron tracks successfully conquered the vast geography of North America, unifying disparate coasts into single national markets.
Yet, they simultaneously deepened the fractures within the very societies recruited to build them. Across the world, empires deployed rail to conquer unforgiving geography. Russia's massive Trans-Siberian network stretched over 9,000 kilometers, cutting through frozen terrain to finally extract the deep reserves of timber, coal, and minerals locked away in the east. In colonial India, the British constructed one of the world's largest rail systems. However, this was not designed as a public utility for the local population. It was engineered strictly for imperial control and resource extraction. The network was deliberately laid out to connect the resource-rich center of the country directly to coastal ports. Over 2 centuries, this logistical efficiency allowed the British Empire to systematically drain an estimated $45 trillion in wealth out of the subcontinent. As these global networks scaled up, so did their physical dangers. Between the severe urban smoke pollution and hundreds of catastrophic boiler explosions, railway companies in the 20th century were heavily pressured to abandon steam altogether and pivot to far safer diesel and electric engines. Throughout the 19th and early 20th centuries, the locomotive functioned primarily as a geopolitical weapon. It was the ultimate tool for asserting state control, conquering impassable terrain and extracting global wealth. Following independence in 1947, nations like India inherited these massive extractive systems and began the long process of reclaiming them. Over the next 75 years, the Indian railway network was drastically expanded and re-engineered to serve the public. A system built to move raw cargo outward was transformed into an internal social and economic lifeline, keeping the country connected. Today, that evolution is visible in trains like the Vande Bharat Express. These are engineless, self-propelled electric trains designed with AI-assisted track monitoring, built entirely within India. A network once designed to drain a nation's wealth now functions as its central circulatory system. By connecting remote villages to major cities, the railway has woven together the social and economic identity of over 1 billion people. Even with modern electricity and AI, traditional rail systems still face one absolute physical limitation: the mechanical friction of steel wheels grinding against steel tracks. To shatter this speed limit, engineers eliminated the wheel entirely through magnetic levitation, or maglev. The Shanghai maglev train utilizes this technology to transport passengers at a staggering 431 kilometers per hour. Instead of axles resting on rails, the train features a guideway lined with powerful superconducting magnets and electromagnetic coils. These magnetic fields actively repel the bottom of the train, lifting it completely off the ground. By removing all physical contact, the train effectively flies along a cushion of magnetic force, completely bypassing traditional mechanical wear and tear. From coal-fired boilers to frictionless magnets, the railway is the primary architect of the modern landscape. These tracks fixed the locations of cities, established national borders, and provided the physical blueprint for the modern world.